I believe deeper learning is where the students are driving their instructions. The students are the ones that are asking the questions and grappling with the phenomenon and figuring out, where do we go next? What kinds of information do we need in order to answer that question? It's no longer for me to give them that information. Yesterday I assigned some home learning for the students to go home and just talk to a family member or somebody that they live with to see if they had any experiences where they experienced a drought or a flood. When they came back today, the first thing I asked them to do was kind of turn and talk with one another, share their stories with one another. And that led right into, okay, this happens everywhere. Good morning. Good morning. Okay. Last night I asked you to go home and talk to family members or to somebody at home. And I asked you to come back to school with some water stories of whether or not they experienced a drought, a flood. Can somebody please share one of those stories for me?
My parents experienced a flash flood in Florida.
A flash flood in Florida. How long ago was that? Was it
Like 3 or 2 years ago, I don't know.
anybody else have one that they'll share?
One of my friends' basement flooded completely because of the rain.
I had a flood in my country, Honduras, and there was so much water, I had a pool in my backyard, and I went to take a swim in it.
So in moving on, I want you to think about what we did yesterday. We talked about our droughts and our floods, and I had you look at some headlines. And in those headlines, you had all kinds of things that were on for drought patterns, and you had flood-related headline patterns there. Yeah.
Like wildfires.
Wildfires is one of them. Yeah. What else?
Warmer weather.
Warmer weather.
Less rain, like very little rain.
Very little rain.
Both the floods and the droughts had like warm weather.
Did anybody agree? Did both floods and droughts said rising temperatures, warmer weather? So could I put that on here as being a similarity?
Yeah.
Okay, I would say that we had some rising temperatures, and you said heat was another one of those words that you used. Any phrases that stuck out when you did that? Yeah.
Them saying it's a new normal.
The new normal. What did we say that meant? We had a little conversation about that yesterday. What did that new normal mean?
It's occurring often.
Okay. Anybody want to add to that?
Like new average or something. Like
How would we know it was a new average, something that wasn't occurring before? How would we figure that out?
If you look at past news,
The temperature.
Temperature data. So we have this new normal. How is it that this rising temperatures, this increase in heat, this new normal that you've said, leads us to both floods and to droughts? What might be causing those temperatures to be rising? And how might those rising temperatures lead to two very different things? One leading to a flood, one leading to a drought. Turn and talk. Turn and talk. Come up with something. What might be causing this?
In the water to like evaporate a lot, and since it evaporates, that causes droughts. I really don't know how warm temperature and like flooding is related though.
And like that causes like a lot of rainfall, so that's why they flood a lot. It's because of like the heat. That's why.
As you know, we always put a little model together, right? And we have to think about, well, what's going to go in our model? We're trying to think of how we can explain these rising temperatures, which we all agree on, are causing droughts and they're causing floods. You have an idea that you want to share?
I said that the hot temperature like is evaporating like ocean water, and it's causing a lot of rainfall because of the evaporation, the water vapor in the air.
So somebody want to repeat what he said? What is Gillexi trying to say about that?
like it gets too hot, and then the water from the ocean evaporates, and then it starts raining.
And it starts raining. So that's going to give us more flooding in that area? Okay. Now, how would that also lead to drought? An idea?
maybe the water could go in the ground, and that's probably why some of the ground has cracks in it and stuff. There's no moisture.
So there's no moisture in the ground? Okay. So it's too dry there? Okay. We need to figure this out, don't we? We have a lot of questions. When putting together a lesson that you're going to have and you want to make sure that it's student-driven, one of the things that I do to prepare is to make sure that I anticipate what the student might say and then use that for how I might drive that instruction. I really would like for them to be able to let me know their thoughts and not worry about if they're right or wrong, And I don't want to react to a student if that's the wrong answer. I want to be able to take that with me and know where I need to have that instruction go. What are some things that we must have in our model?
Like heat.
Heat, okay, what's causing that heat?
Sunlight.
Sun.
You want to have the sun in your model? Okay, put the sun in our model. What else might we have in our model? Yeah. We want water in our model? And what form? Is there any particular form? Does everybody agree with everything I have up here so far? Because remember, when we put our components together, you don't have to use all that we decided here right now in your initial model, but you do have to use some of them if we're coming up with them together. What else?
Like some wind.
You want some wind. Does everybody agree you want some wind? Okay. Okay, we got some wind going on in there? Yeah.
Like the sun evaporating the water from the lakes and stuff.
Good, that's good. That's more like a process, right? So we can go back and forth with that. Let's think about what kind of processes, how does water get moved? And you just said what?
It's evaporated by the sun.
So we would say evaporation would be in there? That's one way that water can be moved. What's some other ways that water gets moved?
Precipitation.
Yeah, precipitation. Let's do precipitation. Precipitation, what else might we need? How else do we move it?
Maybe like some water like underground goes into the roots of the trees.
So you want some groundwater? Would that be more for a component? Okay, we can do that. Okay, and you said goes into the roots of the trees. What that might be called?
Goes into the tree. I don't know.
We can think about it. You can think about it. What else? Come on, what else? How else we might move water?
Condensation.
Condensation, we can have condensation in there. Yeah,
Like mountain runoff, like when the ice melts.
so water runoff, okay?
Like melting ice work as a process.
Wow, this is great. You guys are good. We're going to stop here. That's a lot to have in a model. Now, you know, when we put this stuff together and we put our initial model together, do you have to have everything on here? Do you have to agree with everything that's on there?
No.
Can you put something else on there that somebody else hasn't said yet? Yes, you can. So today what I'm going to have you do is you make your initial model. You're going to get about 8 minutes to do that on your own. And then we're going to come together and we're going to do a mini model. And then we'll come together and do our scientist circle and do our consensus model, okay? Your model is your model. There is no incorrect way to do this. This is your thought process is about you are trying to answer how is it that water is moving from those warmer temperatures to create floods and then also create droughts. You're going to be going to lab tables and you are going to share your models. You're going to put a check mark on your paper for things that are similar to your other models. And you're going to put a question mark if you have something that is different from the other models.
And for my water source, I have the ocean.
Make one more.
You have the ocean, or do you have a water source in like general?
Yeah, I got like a
Do you have a water source? Yeah. And then, like when it evaporates, like it makes water vapor. I have water vapor.
Why is the sun not getting hotter? The sun, it destroys the ozone layer, which makes the sun like hotter for us, but it stays the same temperature. Just it makes it hotter for us. The ozone layer is the only reason why we're not burnt to a crisp.
We need the sun in our model.
Oh yeah, that's definitely like one of the key opponents.
Yeah, we need sun,
Water.
clouds,
I didn't put clouds in mine.
water vapor.
Goes to the lake or whatever water source and it evaporates. Water vapor goes to clouds, it rains. Puddles evaporate,
Oh, do you want to wait?
back up, and then rains again.
Do you want to do puddles? Question mark.
Yeah.
Is global warming causing it?
I don't know. Maybe that would be a question mark. I mean, if you want to put it on there, we can. But we could look into that, right? We can see, is that what's causing those temperatures to go up? Because we've had the sun always, so why is it suddenly changing? Okay, so we got to figure out, one, how are these temperatures rising? But secondly, how are those temperatures rising causing both droughts and floods? So we really kind of have two separate problems, right?
Yeah.
That we have to solve.
Yeah.
So yeah, those kind of things can go as your question mark. They don't have to be on there now, but we might want to put them on as question marks even on our consensus model. They ask a lot of questions, and they realize very quickly that they're not going to get the answers from me. That if those questions will go up onto a driving question board, and we're going to spend time going through those. And those questions that we haven't answered, we keep. And we keep them, and at the end of the year, we'll go through those as well and say, we weren't able to do that. where in the next year or the next curriculum you're going to get to do that. So they gradually learn that they're going to be in charge of their instruction.
I can understand like the heat causing flooding because like that means more rain and like more rain means flooding. But I don't know how like flooding causes heat. That makes like I understand drought.
Usually
Like
the heat causes evaporation from the water.
I don't know how it's the other way around at all.
Does the heat cause the water to rise?
All right, we ready? Now we all know that we have rising temperatures, right? And somehow we have floods and somehow we have droughts. That much we agree. What's causing the rising temperatures? What do we put on here?
In my group, we all agreed that like rainfall was probably like a big cause of the flooding.
The flooding, okay. You guys want to have rainfall here?
Or maybe out of clouds too.
How many agree? You guys want a cloud there? What else do I need? What?
I think you should have a river.
I should have a river. Water like that? Yeah. And I'll just say it's a river.
Yep.
Or you can do two.
All right. And then do it like evaporating from the sun.
Yeah.
This is going this way?
Yeah.
It
Yeah.
goes up to the sun.
And label that as like evaporation.
Okay. How many are agreeing with us so far?
I agree.
All right, all right.
Write the condensation for the cloud because like that.
Oh, I didn't write condensation. I have to write the word condensation. Do you guys all agree?
Yeah.
Right in here?
Yeah, that's fine. That's what I did.
Now I want you to look at your questionable stuff. All the stuff that you had questions about. Take a moment, read through it, and decide as a team what absolutely has to go on that consensus model.
Instead of having like a house on both sides, we could have a house on the flood side and then just a well on like a dried up well on the drought side.
That would show it.
Yeah, that's
Would you like to draw the well?
sure.
You guys all agree? That's a kind of a good idea, right? Yeah. Look at your own individual model. Look at your first initial model. Is there something on there that you really want to see up on our consensus model? Think about it for a moment before we go back. Are we all set? Then everybody happy? In the short term, deeper learning in the classroom for the students, it really allows them the opportunity to grapple with the phenomenon, to work with one another in the classroom, but it opens up their minds to later on and all through life to be able to ask questions, to know that they can ask scientific questions, and that they can also get the information that they need to be able to answer those questions themselves. It gives them that opportunity to know that they can construct good questions and they can find answers to those questions.